Now let's look at this scenario that we have a capacitor coupled two-stage amplifier, and in our case we are now following up on the audio node Paladin, and I just reiterate now that I have not found out whether it's direct coupled or capacitor coupled, so I assume that it's capacitor coupled, as all audio node amps are that I know of. If not, then please leave it in the comments. And now I'm just going with the assumption that it's cap coupled, but if it isn't, then it isn't. However, let's see, why do people cap couple their amplifiers, and what changes when we go to direct coupling. So okay, where to start? So let's see, here we have our power tube, and for the power tube to produce an output signal, it needs to be driven by an input signal that is created between this point and the ground, and this energy is provided by our driver tube. And the driver tube cannot just get connected to your power tube. If you just connect it directly, it's called direct coupled or Loftin-White. Loftin-White is actually a little bit more than just direct coupling, but for all practical sense, direct coupled amps are called Loftin-White amps, and that's what I've been doing in my previous videos. So when I say Loftin-White, I really mean direct coupled amplifiers versus capacitor coupled or transformer coupled. So now let's see what's happening when you capacitor couple a tube, an input or driver tube, to your power tube. And you need the capacitor there to block the direct current, the high voltage. So here in your driver tube, there's a significant voltage on the plate. So if we use a 6S7, then I don't know what is Peter's operating point for the Paladin, but I suspect it would be somewhere between 100 and 200 volts on the plate. So here we have that much DC voltage on the plate, and then there's a capacitor that we put in there to block that DC voltage. And what the capacitor does, it prevents the DC from showing up here on the grid of your 45, but it will allow the alternating signal, which is the music signal, to be present here. However, it does affect that signal, and what it does is, due to the size of the capacitor and the size of the resistor here that goes from the grid to ground, these two form a divider network that will create losses in the low frequencies. So your bass response will go like going here, bang, and then just fall off. Wow, very, very creative design. So anywhere, just, and depending on the size of your capacitor and resistor, there will be a pole frequency where we lose a certain amount of dBs compared to the flat response, and then it will just keep on falling and falling. And as of note, if you increase the value of your capacitor, let's say you go from 1 microfarad to 2, then this pole frequency will go lower, so then this drop will be pushed more and more back. And the same thing happens if you keep on increasing the size of this grid resistor, of the input resistor that feeds the grid. So why not use an infinitely high resistor at this point? And we should not do that, because when you give a really high signal for this tube, then the grid starts pulling current. So the potential of the grid is well below the potential of the cathode, and that's created either by the cathode resistor, or if you use a fixed bias, then instead of that, there is a source connected it that pulls down the voltage of your grid below the voltage of the cathode. And let's just come back here to our current scenario that I'm showing now. Due to the RC coupling, even if it's fixed bias or auto bias, this is also called auto bias when you have a resistor on the cathode, when the signal is so high that the potential, that the signal is coming close to where your cathode is sitting, in that case you will start to draw current through the grid. So the grid will start to emit electrons towards the plate. And if it starts to emit electrons, then this resistance itself will prevent it from emitting those electrons. And what's the problem with that? Well, the problem with that is that those electrons are going to be stripped from the grid anyway, and if this resistor doesn't allow that, then you will ruin your tube, because it will strip it will ruin the structure of your grid. So that's why when you look at tube manuals, every power tube has a recommendation what is the maximum resistance that you can employ for the tube. So that is one factor that will limit what that low frequency turnover point is, where you will start to lose information. But the problem is that due to the capacitor, you are not just using information level, because who cares if you have lost like half a dB or 1 dB, you won't even hear it anyway. If you just place your speakers like 5 inches closer to the wall, that has much bigger effect than you doubling the coupling capacitor. I mean, much bigger effect in the bass response than that 1 dB. So, however, there's another thing that the capacitor is doing. It's not just that the level is rolling off, but the phase is changing as well. So the absolute polarity of the signal is going to be shifted as the bass response shifts. So that can be a problem with this type of thing. However, usually that shift, what designers try to do is make this turnover frequency so low that it's like 20 hertz or 10 hertz, somewhere in the region where it doesn't affect the bass performance. So hallelujah, we are saved, so coupling is great, but it is not, because the problem is that eventually this driver tube needs enough output power and low enough impedance to drive your power tube, and that impedance gets more and more critical as the frequency decreases. So when we are at 100 hertz, all is randy dandy, but when we go down to 20 hertz and so even like at 40 hertz, then we are going to hit roadblocks here with the capacitor coupling. It's going to be more and more difficult. And how difficult it's going to be, it depends on the tube. So in the case of a 45, it's not going to be that much difficult, but if you are look at something like the 300B, the 300B is notoriously difficult to drive. So in any case, if you are driving a 300B through this design, then you are going to lose a lot of bass, and then the 300B will become a mid-range amplifier, and that's why 95% of 300B amps on the market are lady amplifiers. I think that's how they call them in Hong Kong, is that they are perfect for female singing, but they do not have balls, or they cannot really play deep stuff. And that's why the 2A3 tube and amps built with 2A3 usually tend to have much better bass control. If you want to listen to drums, yeah, go for 2A3. Even though 2A3 is like on the average 3.5 watts output power, 300Bs are on the average 8 watt output power. This can be changed a little bit depending on the application. But the 2A3 is much easier to drive. So if you have the same driving stage, and usually most designs use the same driving stages, like 6SR7, 6SN7 are the most popular drivers for these tubes, and some people go to the pains of using a 12AX7 as a driver, which is a huge no-no because it's absolutely incapable of driving a 300B. It's just asking for failure in the bass department. However, why people use 12AX7, I will talk about that later on. So right now, let's turn back to the issue on hand. Let's stay on track, which is capacitor coupling. So here, when you capacitor couple your driver tube to your power tube, and if you choose the values well enough that they stay away from cutting into your bass response, you will still have the problem of not having enough drive. And that's why the big tubes like a 211 or an 845, they sound so much ballsier and gutsier than a 300B or a 45, because what they do is that they use a really powerful tube to drive them. For example, using a 45 power tube to drive an 845, that results in a really good sound. However, in this case, the 45 is driven by a signal tube, which is really wimpy. Like you can get like 2.3 milliamps of current out of it, and that's trying to drive your 45. It's okay in the mid-range high frequency, but when you go to the bass, it poops out. So that's why if you look at like some Thomas Meyer and Oliver Says and Radu Tarta amps, when they use a 45 to drive another 45, that solves the issue, because then even though if you capacitor couple it, you still have enough power to drive it well into the low region. So getting back to direct coupling, so if you go for the direct coupling schema, then you do not need here, so let's say if you have like a 45 power tube, and here we are sticking to our 6S7, it will still stay quite ballsy if they are direct coupled, because when you direct couple the two tubes, then there is a tremendously better current drive than blocking it by a capacitor. And here you are not limited to a wimpy resistor that's blocking the grid's current. The grid can draw as much current as it wants, because there's a tremendous flow of electrons coming through the cathode of the driver tube, and all of those electrons have now direct path to flow through the grid and up through your power tube. So there's no limit in the grid current. So your amp can draw as much grid current as it desires. Plus, there's another added advantage, that when a capacitor coupled circuit, okay, you know what, I tell this in another video, because I've been accused repeatedly of not being concise, and this deserves another topic, another subject. Thank you, bye bye.